So good morning to all. So this is Selkumar from National College of Technology and Diploma of Computer Science Engineering. So now I'm going to tell about what is process concept operating system and the interprocess communication. So interprocess communication, the process is independent if it cannot affect or affected by the other process executing the system. So any process that does not share data with any other process independent, a process is a cooperating if it can be affect or affected by other process executing the system. So clearly, any process that shares the data with other process is a cooperating process. So cooperating process requires an interprocess communications and mechanism that will allow them to exchange data and information. So reason for providing process cooperation, so information sharing, since several users may be interested in the same piece of information. For instance, a shared file must provide an environment to allow concurrent access to such information. So computation speed up. So if we want a particular task to run faster, we want break it into subtasks, each of which will be executing in a parallel with the others. So notice that such a speed up can be achieved only if the computers has multiple processing cores. So modularity. So we may want to construct the system in a modular fashion, dividing the system functions into separate process or threads. So convince that even individual users may work on a many tasks at the same time. So the versions of user may be editing, listening to music, and complaining in the parallel. So model for IPC. Cooperating process requires an interprocess communication mechanism that will allow them to exchange data and information. So there are two fundamental models of interprocess communication: shared memory and message passing. So in the shared memory models, a region of memory that is shared by cooperating process is established process can that exchange information by reading and writing data to the shared region. So in the message passing model, so communication takes place by means of messaging exchanged between the cooperating process. So we have two types of message passing and shared memory. So the message passing is useful for exchanging smaller amount of data because no conflict need to be avoided. So shared memory can be faster than the message passing since message passing systems are typically implemented using systems calls. Shared memory suffers from cache coherence issues which arise because shared data migrate among the several caches. Shared memory systems. So establish a region of shared memory. A shared memory region reside in the address space of the process creating the shared memory segment. So other process that wish to communicate using the shared memory segment must attach it to their address space. Example: producer consumer problem. So producer process produce information that is consumed by the consumer process. The producer and consumer must be synchronized. So this is the example of producer process using shared memory and consumer process using shared memory. The producer consumer problems uses shared memory. So this buffer will reside in a region of memory that is shared by the producer and the consumer process. A producer can produce one item that while a consumer is consuming another item. So two types of buffers can be used. So the unbounded buffers places no practical limit on the size of the buffer. The consumer may have to wait for new items, but the producer can always produce new items. The bounded buffer assumes a fixed buffer size. In this case, the consumer must wait if the buffer is empty and the producer must wait when the buffer is full. So memory shared of the producer and consumer process. If we have a buffer size of 10, the type definition structure keyword is used for the defining the buffer size, and we have a in and out equal to 0. So next one, message passing system. So message passing provides a mechanism to allow process to communicate and synchronize their actions without sharing the same address space. So it is particularly useful in a distributed environment where the communicating process may reside on the different computers connected by a network. So message passing facilities provide at least two applications. One is send and receive message. So methods are logically implementing a link and the send and receive operation. We have a direct and indirect communication and synchronous asynchronous communicating and automating a respective buffering. So first one, a direct communication with a naming. So direct communication, each process that wants to communicate must explicitly name of the recipient or a center of the communication. So communication link in this scheme has two following properties. So first is a link is established automatically between every pair of process that want to communicate. The process need to know only the other identity to communicate. A link is associated with the exactly two process. So between each pair of process there exist exactly one link. So in this scheme, so the send and receive primitives are defined as send p message and receive q message. Send a message to process P and receive a message from process Q. So this scheme exhibit symmetric in addressing. So that is both the sender and process and the receiver process must name of the other communicate. A variant of scheme of employ asymmetric in addressing. So here's only the center names are recipient. The recipient is not required to the center. So in this scheme, the send and receive primitives are defined as follows: send p message, send a message to process B, receive I received id message, receive a message from any process. The variable id is set to the name of the process with which communication has taken place. So this is the direct communication of the entire process of IPC interprocess communication systems. Thank you.